Hi, my name is Ryan McEwan. Here I'm going to present to you make a lesson on creating box plots and bar charts with error bars in GGPlot. You're obviously going to need RStudio and R installed on your machine. We're going to work here in RStudio. We're going to use three packages for this session. The first is Grid Extra. So go ahead and install that package. You'll also need GGPlot 2, and you're going to need RMISC. So you want to install each of those in turn. This is the way I install packages, is the old school R pre-studio way of doing it. I think you can also use this little tab over here called Packages. But this here will work just fine. If you have another way of installing packages, you can use that. So go ahead and pause the video and make sure you have those installed. Okay. Everything good? Make sure these things finish running before we do anything else, okay? You can't do something else in R while the package is installing. All right, so activate GGPlot like this. GGPlot is a popular and flexible data visualization tool. Activate Grid Extra like that. Grid Extra allows for quick organizations of graphs. I will demonstrate that to you. And activate RMISC. Honestly, I don't know what all this package does, but one thing it does, which is very useful, is calculate summary statistics, which we will need for our bar plot. There are probably dozens, at least, of ways of doing what I'm about to do here. And my way is not to be taken as the capital T, capital H, capital E way. It's just a way. Okay, so we're going to actually work with a data set that is already installed on your machine if you have R, which is this iris data set. You don't even actually need to install it. As soon as you install R, you already have it. It's one of the base data sets. Now, you could just take a look using a view iris like this to see what you got. You've already have it. Here it is. Sepal length, sepal width, petal length, petal width, and species. These are species of iris. And those are flower characteristics. They're quite cute, actually. I should have a picture of an iris to show you what that is. I do not. We have these four parameters, and we have these different species. If you scroll down, you can see versicolor, virginica, and the first one was setosa. This is already in the R package, so no need to install data for this exercise. So the first thing I want to do here is show you how to create a graph of this data set to visualize it. And this is a bit detailed, and I'll talk you through it. But first, pause the video and type in this code. I will play some drums while you're doing that to help you get excited. So here we've got iris is the data set. This says aesthetic element, which means draw something. X is going to be species, and we can again go and look at the data set here and go, oh, species, see this column? See my cursor right here? We're going to put species on the X. We're going to put petal length. You could pick another variable, doesn't really matter, but we'll put petal length on the Y, petal dot length. All of this matters, by the way. So capital S for species, it has to be capital S. If you put small s species, it's not going to work. Petal dot length, it can't be comma, it can't be space, it can't be dash. It has to be petal dot length because the computer, the program, doesn't know what you're talking about. If you put petal space length, it goes, that's not a thing. It has to be exactly that, petal dot length, and the L also has to be capital. So it has to match perfectly. Then we're going to say comma here, fill equals species. This is pointing back to this species. Fill is, that's going to allow us to draw or to color the boxes. I'm going scale, fill, manual here. So this is the colors we're going to use: turquoise, orchid, and khaki. Those are nice, quite nice colors. R has many, many different colors. If you don't know, you can go colors, open and close, parentheses. If you're like, I don't know what colors are in R, just highlight this and run it. And you'll get down here, see down here in your console, all these different colors. Okay, there's lots, there's how many? Almost like 100 different grays, for example. So plenty of colors there to play with. Then I'm going geom point. I'm going to go alpha. That's so you can see through it. See these points you can see through right here. Size is 3. You can change the size, make the bigger or smaller. And then I'm position jitter. This just makes the points separate a little bit, and it's a random thing. There's no particular reason to do it from a statistical perspective, but from a visualization perspective, it makes it nice. Now, why do you want the points also? Oh, finally, geom box plot here. Now, one thing to say is I put the box plot last, and there's a plus. Don't miss the plus. Last, because this puts the points on top. You know, you can flip it the other way, but this way you can see the points. You could also, and I'm also alpha a little bit the box plot as well, so you can make it a little bit transparent. You can swap those back and forth if you're like, I want the visual to be different. In any case, this is a nice graph displaying your data. So if you take a look over here at the graph, you can see this is each of these points is one of the samples. So this is a sample size estimate, which is nice. And you can also see the distribution of the points to see if there's any outliers. The black bar here is the median. So you can go, okay, Setosa is obviously, just like from a visual perspective, lower or shorter sepals than Versicolor, which seems to be also shorter sepals than Virginica. And there's a little bit overlap here, but the boxes actually are separate. So this looks pretty clearly like Virginica is the longest petal length. Okay, so this is a nice graph. I wanted to show you this as just a way to get started. Here's a couple of other little additions to this if you want to make it even nicer. I'm going to throw up a plus here, and I'm going to go theme classic. I'm going to go theme legend.position. I'm going to move this legend out of the side pocket here, or this alley down here in the graph. And then this is theme panel.border. I'm just going to put a black border around this. I think putting all of that in play makes this a really nice data display. We can tinker with the exact position here. Oops, looks like the legend's a little too low, so I might move this up a little bit more. There we go. Yep, so I just moved this up a little bit. You can move the legend position how you want it here. So there you go. This is a pretty nice data display. Go ahead and type the code, run the code, and now you would have a box plot. This thing's ready to go to your committee, or ready to go, pretty close to ready to go to a journal, actually. So this is a really nice way to display data. Okay, so this is just using sort of the regular data set, geom point, geom box plot, and a little customization. Let's take a look at bar charts and error bars now. If I were displaying group data, this is the way I would do it, just like this. I might tinker with it a little bit more, but this is the general notion. However, a lot of people like to have a bar chart and error bars. And so to do that, you actually need to give the GGPlot the values. They're not going to, GGPlot, at least to my knowledge, isn't going to calculate those values for you. And this is where we're going to use this RMISC. And what we're going to do is define and create a new data frame. IRIS. I just called underscore ER here. You can name it whatever you want. That doesn't really matter. But just to follow along with me, just iris underscore ER. That's like iris error, so we're going to calculate the error or variance. And we're going to go a little caret here. Summary SE. Iris is the name of the data set. We're going to go measure var is measure the variable. Quotes petal dot length, because that's the one we want to use here. And group vars, that's group variable, is species. And here's a C concatenate. So this is like if you wanted to do, this thing has a lot of functions, but here we're going to do just a simple thing. So then you highlight all of this code and run it. And that's going to define a new data set. And then you can view this data set like this, view IRIS underscore ER, and take a look. It'll pop up here as its own data set. And you've got species, N is the sample size, petal length is your variable, and this is going to be the mean now. And then you've got SD is standard deviation, and SE is standard error. This is CI is confidence interval. We're going to use SD, but you could also use SE. That would be standard error of the mean. SD is standard deviation of the mean, and this is the mean. If you don't know what standard deviation or standard error are, you'll have to get a textbook and look it up or use the internet. Okay, so what you've done here is created a new small data set, and you can use that now to graph. So to make a bar chart looks like this. And if you don't do this, you can't do it. Okay, so this is the way to do this. Is you can calculate it some other way, but to get the mean and the error variables, the variance, you need to create this small data set. And once you've done that, then you can create a bar plot like this. So here I'm going, well, I'll let you type the code. Type the code, run the code. Helpful. You should get excited. So if you got this code to work, let me just walk you through it now. So what you've done here is iris ER. Now that's pointing to this new little data set you've created. X species, again, Y petal length, fill species. It just allows us to color the bars. It's not strictly necessary, but it's useful. We're going to go geom call, okay? Position dodge, color black. That puts a line around the edges of this. You just position dodge open and close. You can look into it later if you'd like to learn more about position dodge. Geom error bar, that's going to draw these error bars. And then aesthetic element means draw them. And then here we're literally defining what we want. Y min, that's like telling it how far down to go, and min or max can be flipped here, I believe. That's just like how far to go down on the y-axis is petal length minus SD. So now your error bar is going to be exactly the length of one standard deviation. Down. Y max equals petal length, and in your data set here, that's the mean. Okay, that's what is calculated. Y max is the mean petal length plus SD. Aha. Position equals position underscore dodge 0.9. Again, this is just matching your regular position dodge. Why we need to define it this way, I'm not entirely sure. You can look into it. Width is the actual width of these little caps, the little TIE fighter wings. Bingo. Bar chart with error bars. You got it. Now, Show you how to do something else. I'm calling this a Holmes plot. This is because a person named Katie Holmes showed this to me. I don't know if it has an actual name. This is the name I'm calling it, Holmes plot. And here we're going to go GGPlot iris ER. We're pointing back to that same small data set we created. Aesthetic element X species Y petal length. We've already done this up there. I'm going shape species, color species. Okay. Geome point size 4. That's just size of whatever you want. And then error bars, which are the same error bar code that we just had up here. Same error bar code. So the error bars are the same. And if you run that code, you get this. This is a different kind of a nifty chart. I see people nowadays drawing the chart like this. So pause the video, type the code. Here's some more drumming. Got it? This is a pretty sweet little data display. And here what you're graphing is the mean and then the error around the mean. So especially if you're calculating if you're running like a regular ANOVA or something where you're using the mean and error, this could be an interesting way to display the data. Now we can compare and contrast these, and I think it is useful to do that from just a conceptual perspective. Here I've written the word Holmes, but you could have, that's because I'm calling it a Holmes plot, and you can run this. This is just defining all of this graph as Holmes, and here we can do this bar chart. See, I've written the word bar up here and put this little caret here. You don't need this to create the graph at all. In fact, it's not helpful, but what you can do is define it this way, and then we can take a quick look using you can use grid.arrange to arrange the charts like this. This is one up on top of the other, or you can do number of rows 1. I want to see them side by side. This is a quick way, and this is using Grid Extra, which you installed earlier. This is a quick way, if you've not seen this before, this is a quick way to take a quick look at charts side by side. So this gives you a sense of kind of what's going on with this. We don't have the Y scale is not exactly the same here, so we'd have to adjust the Y lim to make them match exactly. I'm not really interested in that. I just wanted to show you how to do grid arrange, because it is quite useful if you want to plot, for example, side by side. And you know, we wouldn't do this in a publication or a thesis or something like this, but you could use it just to look at data or use it in other contexts. And you can stack them like this or stack them side by side. And I just wanted to demonstrate that. This is like the old par MF row or whatever that we used to do in base code, but grid arrange is a nice little package to use at times. So one last thing to do here. So I've showed you how to do I think a really high-end data display just using a box plot. And if I were going to use this is back up to the code I typed a minute ago. If I was going to display this data set because it was in my thesis or something, this is how I would do it probably. I would get rid of the grids in the back and do something like this. This is a really clear and nice data display. I might play a little bit with the alpha and go, I want it to be a little bit different. I might swap the position of the box plot and the geom points to just like tinker with it and see, well, what's the best display here overall. But I'm pretty happy with this. If your thesis thesis mentor were like, oh, I really want you to make a bar plot, then you can do this, which I've demonstrated how to do that as well. In this case, you're pointing the bar plot at this other small data set, which you've calculated using the summary SE function, which is part of this RMSC package. All right, nice, got a bar chart. Of course, you can adjust everything about the bar chart too. You can get rid of the gray thing, put a box around it. You can scale, fill manual to pick the colors, etc., etc. So this is not the end, but maybe only the beginning. Or if you want to get sort of like new agey, you can do this. People kind of like this now. I see this in science presentations sometimes. It's just like make the plot simpler. Whether or not this is particularly better or worse, I would say worse. Personally, and I would definitely theme classic this thing to get rid of the gray. It's a little bit unclear to me, just to make it a little sharper. But to me, it's clearly a worse data display than this. This is clearly better because you've got sample size and outlier detection and medians and stuff on there. But some people like that. The last thing I wanted to do is show you something. I haven't seen this one before. This is what's coming up here. This is a long and complex bit of code, but I'll just highlight it here. Type the code, run the code, and then one last drum solo for you. Oops. Okay, I'll walk you through this. This is an interesting, I really enjoy this. Here we're actually pointing GGPlot to two different data sets. And so the format of this is a bit different. You may not have done this before. So we're going GGPlot open close plus geom point, and this is pointing to our data iris, or this is pointing to just the iris data set, this one, which is all of the data. And if you're going to do this format, you have to call, or you have to tell it where to look for the data, basically. So you got to say data equals iris. And then AES is aesthetic element, species, comma, petal length, and alpha. These are all descriptors of that particular, this particular graph. And just to break it apart so you can see what's going on, we can just do this. That's just the points. See that? And the reason why you might like this is because, in fact, you can write your code this way. If you just want to write a boxplot code or whatever, you can add it like that, like this, as long as you call out the data set in this way. The reason why you would like to display it in this fashion is because some people, like me personally, like to see if it's relevant, the sample size. Sample size is, in almost all cases, something I want to know. So it's nice to have it if you possibly can, if you can get your thesis advisor to agree. And then below that, this is the error bar code and the geom point code from this graph we just made, this what I call the Holmes plot. So what we're going to do is lay this on top of those points. And to do that, we have to use this format, the GGPlot open close plus. And we'll call geom error bar here, but we have to also identify the data set. So we have to say iris, now ER, which is the small one. So we're going iris ER, and then aesthetic element X is species. And we talked about this just 10 minutes ago or something. We're going to call out the exact length of the error bars. Here's the minimum is petal length minus SD. Y max is petal length plus SD. Color, species, position dodge 0.9. We talked about that already. And I just got rid of the little caps here. And then this is just the points for the center of those which is again data, iris, ER, aesthetic element, X, species Y, petal length, shape, species, color, species, size 4. And then theme classic, theme panel border is just like wrapping this up. Of course, if you don't want to do that, you could leave it like this and leave the gray, default gray bars behind it and leave the box off. But I like I like to have, well, you can leave it like this, but it's a little bit clearer in my view if you take those off using theme classic and then put a box around it. It's a little better. And then yeah, I would in addition to this, I would also potentially move this legend down here, which we did that up above. So this is the conclusion. I don't know if you would like to make a chart like this, but if I were going to make a chart like this Holmes plot, I probably would like to have the sample size in behind that. So this concludes my session on bar plots, box plots, and what I'm calling a Holmes plot. Thanks for watching, and see you next time.